Hi everyone, welcome to my channel. Today in this video I'm going to cover end-to-end architecture for real-time data processing. Trust me, this is one of the most demanding skill in data engineering. So there are many use cases which are already getting solved with the help of real-time data mining or real-time data processing. So we have use cases from banking where fraud detection, we have use cases from stock market, we have use cases from IoT where sensors are getting data. We have lot of use cases from custom centric data where events are getting captured and lot of analysis are happening in terms of how many downloads are happening for that particular product, how many users are using that product, how many new signups are happening in healthcare, in manufacturing, all like you name it, everywhere real-time data mining is happening. I will create a detailed video where I will showcase how we can end-to-end, starting from their installation, then what it takes, configuration, everything, what it takes to build end-to-end project for real-time data processing. I'm sure by understanding this architecture, you will have a solid foundation and then you'll be able to solve many problems with the help of this architecture. So let us start from the basics. The very first thing in data world is, if we are talking about any data flow, any data architecture, it starts from data sources, which is true for real-time processing architecture as well. So we have data sources. Now data sources could be IoT in the form of a lot of sensors, sensor in the form of, let's say, machine sensors are there, temperature sensors are there, which are generating a lot of data, location sensors are there, which are sending the location data, social media data, which is generating a lot of data from the social media, event tracking system where we are getting data from a lot of events are happening with respect to a product, a lot of things are happening. So we have couple of sources. These sources could be part of your system or could be outside your system. The very first thing is that we have to bring these sources into our system so that these sources, the information that is flowing through these sources, we could process that information. That's why the very first thing is the ingestion layer. It may happen that, let's say, your data is getting generated in the cloud, but you have to process this data on on-prem system or vice versa. So for that one, we need to bring the data and we need to ingest the data in our system. How we can do so? So there are multiple ways. First is maybe we can write any custom code or we can write any connectors so that we can start getting data from these sources. Or other ways or efficient ways using some ETL based tools which are capable of getting data from different sources like NiFi, stream sets, and we have couple of tools from cloud offerings as well. NiFi is one of the most widely used ETL tool because being an open source and it offers 200 plus different connectors. It's very easy to use and it offers a lot of capabilities in terms of reading from different storage options, different NoSQL databases, messaging queue, and other things. So intent is to use any ETL tool. We could use any of the ETL tool, whatever is present in our system. Create a connectivity or create a pipeline to bring all the data into our system. So once the data has been ingested into our system, so next part is we need a pub/sub system or a messaging queue system because these systems are capable of stream processing. So why do we need this distributed messaging queue system? They are capable of processing large amount of data in a streaming way. The information could be persisted. They provide the fault tolerant. They provide a guaranteed delivery, and they provide a clear demarcation between a publisher and subscriber. So both are independent. Multiple publishers could write it. Multiple subscribers could read from a same publisher. So there are multiple ways. So while processing the data through streaming, so we need a way where if something goes wrong, there should be a way that we could read again from the source. If we have a semantic like we have to read a data exactly once, then there should be a way the platform or the capability should be able to provide this kind of mechanism. So that's why we need a distributed messaging queue kind of system for a real-time processing or a stream processing. And one more point. So it may happen that suppose your data sources are actually writing directly data into this layer. So for that one again, then in that case, we don't need this ingestion layer. So what I'm saying is if there is no way that where our data is directly writing into Kafka topic, for that one we need an ingestion layer so that we could read from the sources and create a ingestion layer or write into Kafka or similar messaging queue system. But if we have already a way where our data sources are directly writing data into Kafka, then we don't need this ingestion layer. We can directly start from here and then we can move to the further steps. For a pub sub, we have again a lot of solutions, like we have Kinesis, we have Event Hub, we have pub sub system from Google, but one tool that really rules the market is Kafka. Kafka has become a de facto standard in the industry for real-time processing. Once we have data in the ingestion layer, then we have to push the data to our pub sub system. We have collected the data in some pub sub system. The next is the processing layer. Now, stream processing could also be categorized into two categories right now: near real time or real time. Near real time, we have systems like Spark streaming or structure streaming, which works on a micro batch principles. They are not truly streaming. They works on, let's say you configure a batch of 1 second or 2 seconds, whatever the data gets collected in that 1 second or 2 seconds, that data would be processed in the form of batch. The upside is it gives you very high throughput, but downside is if you have a truly low latency kind of requirement, it might not meet that one. Frameworks like Flink, which is a truly stream oriented solution. It's a very powerful open source thing, which has gained a lot of attention. It gives you a lot of capabilities. It gives you low latency, truly streaming solution. And similarly, we have Akka Stream, we have Kafka Stream. Let's say you have built an ecosystem where you're reading data from Kafka, writing into data into Kafka, then you can use Kafka Stream. There are other aspects also related to choosing the stream processing engine, like how it handles the back pressure, how it handles the fault tolerant, does it support the stateful or stateless processing. It offers different windowing capabilities. These are the few things that we need to consider before choosing any streaming. But the point is, once you have collected the data in the form of Kafka, you need a stream processing engine which could process the data. So now you're processing the data here. The stream is coming, the data is flowing, and you're just keep on processing the data. It's your business logic, whatever you have to do. Let's say we wanted to see whether fraud is happening or not, or you wanted to see whether a particular event is happening and then we need to trigger something, whether you want to see that if you want to capture a particular keyword, that particular keyword is happening in that particular event or not. So all these things are logics are happening in the stream processing. Now, how we have to move to the next step. So once you have processed that one, next we need a solution which is capable of fast ingestion, which can store the data with a high volume, which can give us the data or insights in real time. So we have solutions like Druid or Pinos, which are fast ingestion framework where we can insert millions of records, and we can also prepare a OLAP kind of system on top of that. Or if we have a requirement where we don't want the OLAP kind of capability, but we want a searching capabilities, then we could look for a solutions like Elasticsearch, Solar, where we are ingesting the data in high speed, and then in real time we're able to search the event. In real time we are able to do the analysis on those events. And here we could also maintain some NoSQL data store as well. Like we can maintain Cassandra, we can maintain MongoDB, and then there could be an application which could work with these data stores like Cassandra or MongoDB to take further action. Finally, once we have stored this data in the form of some high ingestion or indexing kind of solution or a NoSQL databases, then we want to visualize that information. Let's say we want to generate some report, we want to visualize the information, we want to generate some alert in real time, and we want to see our whatever is processing in real time, or we want to do some analysis in real time. For that one, then we could visualize the data in the form of Kibana, Power BI, Superset, and other visualization tools like that. So intent is you are getting a data in stream where you are processing the data in stream, and then you are putting the data in high ingestion, fast ingestion framework and aggregating those matrices and results, and we are able to visualize those information in a real time using visualization techniques like Kibana, Superset. And here then we could build a lot of dashboards, we could build different reports, we could build different apps, so that in real time we are able to see what is happening in our system. And here we could also build our logic, application logic. If something would happen, then we have to generate alert, or we have to take some corrective action out of this. So all in all, if you see, In this, we had covered a couple of steps, right from getting the data from different sources, and then we have to ingest the data using different ETL tools. We could use open source tools or cloud-based tools or other tools. Or if we don't want to use any tools where we know that ETL tools cannot work, then we would have to write our application code, or we would write our custom code so that we can read data from different sources. Once you have got the data from outside to your system, then we need some PubSub kind of system or messaging kind of system where we can store the data as a persistence layer, and it should be capable of giving us a streaming capability. So we know that Kafka, Event Hub, all these systems are capable of giving us streaming kind of capabilities where we can process the data in stream. And once you have data in Kafka, then we have couple of solution which can work on this messaging queues or messaging broker and start processing data in real time or near real time. And then choice of choosing this framework depends on a couple of factors, like what is the latency, how much throughput we want, do we want to maintain any back pressure, do we want to maintain any complex state, do we want to maintain any windowing kind of capabilities. So a lot of factors are there on which basis we can select that one. And once we have started processing data, then we need a fast ingestion layer or a storage layer where we can get all this data, and then we can aggregate the data and then generate insight out of that data. For that one, we have couple of solutions as we discussed, that we have Troid, we had Pinode, we have Solar, or we have Elasticsearch also. In near time, if we have a capability where we want to capture and we want to do some analysis and we want to search any event, we want to do some real-time data mining, on that basis we could choose these solutions and then build a storage and aggregation layer. Once we have built an aggregation storage layer, then we could build an application on top of this layer, or we could visualize the data using different tools by which we are able to generate the data, we are able to see the data in end-to-end. Now, whatever the architecture that we are discussing right now, in a future video I'll cover at high level the running demo of each and every component, where starting the source, ingestion layer, Kafka, Spark, other things, and then we'll be able to see that in a fraction of, like in 1 second, we are able to generate the data. We are able to see that whatever the information that we did, we are able to see that information in real time and able to analyze that information in real time. So in this video, we try to learn end-to-end architecture for real-time data processing. We covered lot many details in terms of different stages, and then each stage we had a lot of technologies options and on which basis that we have to choose which technology and why. By following this architecture, we can solve multiple use cases of real-time data mining or real-time data processing. Thank you so much for listening to me. I'll see you in the next video. Have a great day. Thank you.